Hello students, welcome to the next lecture on the ordinary differential equations. Today I will explain you the concepts about the existence and the uniqueness theorem. Make sure student the existence and uniqueness theorem is applicable to the initial value problem which is defined corresponding to the first order first degree. Fine. So myself Dr. Harish Garg, you can follow and subscribe my YouTube channel. What we have discussed so far, we have learned the concept of the Lipschitz condition, Picard's method, Taylor's method, and many more lecture in this playlist. You can follow ordinary differential equations at my channel, Dr. Harish Garg. Now, what is the objective of this today's lecture? We will see what is the existence and the uniqueness of the first order, first degree differential equations. After that, I will also explain you what is the existence and the uniqueness of the second order differential equations. But right now, this lecture is limited to the first order differential equations. Make sure students, throughout my lecture, I have used the one notation. Wherever you will see the y dash is denoted as dy over dx, where y is known as dependent variable and x is called as independent variable. Fine. So sometime the existence and uniqueness theorem, some authors have defined the dx by dt. Fine. In this case, x is my dependent variable and t is my independent variable. So I will explain you the whole lecture with the help of the dy by dx. And if you are reading some books where the dx by dt is replaced, fine, then you can replace y to be the x and x to be the t. Now, the first question arises if you look about these three simple differential equations. The first question is always arises in our mind. Can you say the solution of such kind of the first order first degree always exist? That's a very crucial question arises in our, that's our curiosity. हमेशा हमें लगता है कि क्या solution exist करेगा, अगर करेगा तभी तो हम solution निकालने की कोशिश करें. And second curiosity is always occur in our mind is, can you say when the solution will be unique? When the solution will be unique, because we always interested to find the unique solutions. Fine. So how you can find the unique solution? When the solution will be existence, that will provide you the existence and the uniqueness theorem. And it's a very, very important lectures from the theory point of view as well as the CSR net, GATE or any other competition examinations. Fine. Moreover, these are the students of the BSc or the BTech students as well. Now, if I look about these three firstly examples and then I can extend it to the journal form, can you find the solution of this problem? Yes, you can do. If you integrate on the both side, then you will get y is equal to x square by 2 plus c. Now, the initial condition y of 0 is equal to 1. What will happen? C will be 1. So you will get the solution is y is x square plus x square by 2 plus 1 is my required solution. And now you can see there is no arbitrary constant c involved in the final solution. Therefore, you will get the unique solution. Fine, because there is no arbitrary constant involved. If you look about the second example, first of all, you can see whenever x is 0, y is equal to 1. The equation is a 0 by 0 form. Fine. So can you integrate them? If you write as a dy over y minus 1, which is equal to dx over x, and if you integrate them, the left hand side integration becomes log of y minus 1 and it is log of x. I choose the constant as a log of c, which implies y minus 1 is equal to cx. Now, based on my initial condition, y of 0 is equal to 1. Can you find the value of the c? Y of 0 is equal to 1. So what is the value of the c? Can you find that? No. You can never find the value of the c. On the other hand, if you look about this case, again, if you integrate on the both side, the left hand side is y, which is equal to log of x plus c. If I substitute y of 0 is 1, can you find the value of the c? Because 1 log of 0 is infinity, that's not defined. So c you don't determine that, or you can't determine that. Fine. So that means whenever you have unable to determine the value of the c, you will get the infinitely many solution, because for the different value of the c, if you choose c is equal to 1, that is also the solution. If you choose c is equal to half, that is also the solution. If you choose c is equal to minus of 3, that again it's a solution. On the other hand, if you look about this function 1 over x, clearly say whenever x approaches to the 0, fine, the function is infinity. Fine, that means it has the no solutions. So what you have observed from these three examples, the initial value problem may have a unique solution, initial value problem may have the infinitely many solution, initial value problem may have the no solution. And that's why our major target is, when the question arises, is when the solution exists and when it will be unique. Clear? That's a simple motivation behind the existence of the uniqueness theorem. Fine. वीडियो को लास्ट तक देखिए, you will learn many new concepts. Clear बच्चों? Now, so from these examples, what we have concluded that for any initial value problem, dy over dx is equal to f of xy may have no solution, may have unique solution, or may have more than one solution. So our curiosity is, we have to learn the two fundamental questions here. What is the guarantee of the existence of the solutions? At least one means the existence of the solution. Existence means कम से कम एक तो solution exist करे, और at uniqueness means exactly one solution. फाइन, हमारा टारगेट हमेशा एग्जैक्टली वन सोल्यूशन निकालने का होता है. So the my two fundamental question is always arises, under what conditions, what is the condition on the f we can impose, what is the condition on the x naught we can impose, or what is the condition on the y naught we can impose, so that the given initial value problem 1 will provide you the at least one solution, will provide you the unique solutions, and that is called as the problem of the existence and the problem of the uniqueness. Fine. That is all about the motivation, why there is a need of the existence and the uniqueness theorem. Fine. और रिजल्ट जो है इससे भी मजेदार है. Fine. So आप बने रहिए. Now, so we will firstly concentrate on the first order differential equations. Make sure the coefficient of the y dash to be 1. अगर आपके पास differential equation कुछ ऐसी है, 2y dash minus y is equal to x. Fine. So you have to firstly find the coefficient of the y dash to be 1. तो बाकी सबको उधर ले जाइए. Then y plus x divided by 2. And this number x plus y divided by 2 is called as the f of x comma y. Make sure the coefficient of the y dash need to be 1. Fine. Then we will find the condition at which the initial value problem has at least one solutions and no solutions. First of all, the word about is a solution. Fine. किसी भी initial value problem IVP, that is the initial value problem. Fine. किसी भी initial value problem का solution किसको कहते हैं हम? The first condition arises is any initial value problem is said to be the well posed. Fine. If whatever the solution, your target is to find the solution of y is equal to some function of the x. That is your target. Fine. That is my solution. Clear? So how you can find the solution? So whatever the solution you have obtained, first of all, any problem is said to be the well posed if it has a solution. इसका मतलब no solution नहीं होना चाहिए. Fine. Infinite solution हो सकता है और unique solution हो सकता है. Fine. Second is the solution must be unique. Infinite case भी आपका cancel हो गया. And whatever the solution you have obtained, that is dependent on the initial condition y naught and the function f. Fine. If any function is dependent on these three features, then you can say yes, the function is said to be, or the initial value problem is said to be well posed. Like the same example we have considered. Fine. Y of 0 is equal to 1, and we have seen the solution obtained is the problem is x square by 2 plus 1. The first condition satisfied. Fine. It has a unique solution satisfied, and it depended upon the initial data y naught. Yes, because आपने c कहाँ से निकाला था इसका? जब आपने c निकाला था इसके लिए x square by 2 plus c, that C is dependent upon the initial condition. Fine. और अगर मैं इसको solution को एक्सकेयर कर दूं फॉर एग्जांपल, तो ये solution आपका चेंज हो जाएगा. Fine. So that means the solution is dependent upon the function f, function y, and so. The first and the most important concept, the first and the most important concept of the initial value problem or the existence and uniqueness theorem is defined on the open rectangle. कभी भी बच्चों आप एग्जिस्टेंस एंड यूनिकनेस की बात करो, सबसे पहले हर क्वेश्चन में आपको ओपन रेक्टेंगल डिफाइन करनी है. फाइन. अगर मैं कोई पॉइंट ले लूं, लेट्स से x नोट एंड y नोट. फाइन. सो इफ आई से दिस पॉइंट इज माय x नोट, this point is my y node. Fine. You can consider the rectangle, consider the open interval. This is my open interval. Fine. Or you can consider the closed rectangle. Choice on you. I can define this interval is x minus x naught, which is less than equal to a, and y minus y naught is less than equal to b, where a and b all are my positive numbers. Fine. Or you can also say like a and b are my positive numbers. Fine. Then you can say that if I consider this is my S, collection of all those elements of the x comma y which satisfied by this condition is known as the open rectangle. Any rectangle about the point x naught y naught is the set of the point x comma y such that x minus x naught, this is the point x naught, x minus x naught must be less than of the a and y minus y naught is less than of the b. तो यहां से आपको if you want to find what is the value of the upper bound, fine, and this will be minus b. तो इसका मतलब ये जो पॉइंट आपका ये क्या हो गया, this is the y naught minus b and this point is y naught plus b. Similarly this lower point is x naught minus a and this is the x naught plus a. Fine. सबसे पहला काम हर इनिशियल वैल्यू प्रॉब्लम पे इसको रिटेंगल को डिफाइन करना है. दैट रिटेंगल इज कॉल्ड एज द डोमेन ऑफ द इनिशियल वैल्यू प्रॉब्लम. और जब भी हम एग्जिस्टेंस एंड यूनिकनेस की बात करेंगे, सिर्फ इस रिटेंगल के अंदर की बात करेंगे हम. फाइन. क्या इस रिटेंगल के अंदर सॉल्यूशन एग्जिस्ट करेगा, whether there is existence of the solution in this rectangle, or can you say there exists a unique solution inside the rectangle or not. बाहर चाहे यूनिक सोल्यूशन मिले चाहे ना मिले, एग्जिस्टेंस हो चाहे ना हो, we not bother about that. Our target is to look only inside this rectangle. Fine. बाहर की कोई गारंटी नहीं है. Fine. Now let's come to the existence and uniqueness theorem. That is also called as the Picard's Lindorff theorem. Make sure students, again मैं बार बार कह रहा हूं, the coefficient of the dy by dx must be 1. Now once you have the initial value problem, like this is my initial condition, we can define the rectangle corresponding to the initial value problem. First of all, we can define the rectangle about whatever the initial point is given to you, x naught and y naught. और मैं फिर बता रहा हूं ये कैसे rectangle डिफाइन करोगे, based on this condition. Fine. Now first of all, you can define the open rectangles about the initial points x naught and y naught such that now the two question arises, when the solution will be existence and when the solution will be unique. A very simple case, the initial value problem has the existence solution whenever this function f, whenever the function f is continuous. That's it. Whenever your function f is continuous in the rectangle S. Fine. Whenever your function f is simply continuous, bounded है नहीं है, differentiable है नहीं है, we never know about that. If the function is only continuous in the open rectangle S, then we can say the initial value problem must have at least one solution. Like if you, okay, example मैं आपको इसके बाद बताता हूँ. Fine. और uniqueness कब होगा, whenever the function f and partial derivative of the f with respect to y both are continuous in the rectangle S, then you can say the solution has the unique solution or the initial value problem has the unique solution. Make sure students, it is the del f upon del y. Here y is my dependent variable. Fine. मैंने जैसे स्टार्टिंग में बताया, if somebody will use the initial value problem, dx by dt is f of t comma x. So can you let me know what is the dependent variable? X is my dependent variable. उस केस में ये कंडीशन क्या हो जाएगी? f and del f by del x. Fine, because x is my dependent variable. So if the function is continuous, fine, then you can say the existence. If the function and its the partial derivatives are continuous, then you can say it's a unique solution. Fine. अब अगर आपके दिमाग में del f by del x को लेकर क्या है आपके दिमाग में? As we discussed in our last lecture, that is the Lipschitz conditions. Fine. So the second form of the uniqueness is whenever your function f is a continuous, whenever your function f is continuous and partial derivative of the f with respect to y is my bounded, is my finite number. Fine. Then again you can say the condition will be satisfied the uniqueness. Or in other words, you can say the function is satisfied to be Lipschitz conditions. Fine. So for more detail about the Lipschitz condition, I recommended always to you that you can watch about my previous lectures, Lipschitz conditions. You can see that the lecture Lipschitz conditions and the 20 plus examples of the Lipschitz condition. That lectures are very, very, very beneficial for all of you. Now, so what is the summary of that? If you consider any rectangles, then the initial value problem has the solutions if the function is continuous and the functions and the partial derivative of the f with respect to y both are continuous, then you can say it has the unique solutions. Fine. Now, once you know it's a unique solution, make sure the unique solution is only occurs in this rectangle. ये आपकी जो भी rectangle है, fine. This is my rectangle about the point x naught and the point y naught. ये existence solution of the existence and unique solution we are talking about in this region only. ये आपकी डोमेन है. इसके बाहर क्या होगा we never know. Fine. क्वेश्चन ये उठता है कि अगर तो इसका सोल्यूशन यूनिक हो गया तो क्या वो पूरे इंटरवल में होगा? इस पूरे की लेंथ कितनी है? x माइनस ए इज लेस देन इक्वल टू ए. और अगर पूरे में नहीं है तो क्या वो सिर्फ इतने पोर्शन में होगा? अगर मैं इसकी सब रिक्टेंगल डिफाइन कर दूं, फाइन, तो क्या सिर्फ इतने में होगा? फाइन. हाउ यू कैन नो अबाउट दैट? क्या वो पूरे में है कि इसका सबसेट में है वो? फाइन. फॉर दैट केस द सॉल्यूशन इज एग्जिस्टेंस इन द डोमेन x minus x naught is less than equal to h, and that is called as interval of existence. फाइन. सबसे पहले एग्जिस्टेंस का पता होना चाहिए. एग्जिस्टेंस कब मिलेगा? एज आई मेंशन यू द फंक्शन एफ इज कंटिन्यूस. फाइन. और अगर फंक्शन कंटिन्यूस है तो उसका सॉल्यूशन एग्जिस्ट करेगा व्हेनेवर x माइनस x नॉट इज h. फाइन. एंड h इज डेफिनेटली बी लेस देन ऑफ द a, लेस देन इक्वल टू a. मतलब अगर आपका यहां तक पूरा लेंथ a है, फाइन, तो आपका h जो है वो लाइज इन बिटवीन देम. फाइन. तो ये जो आपका इंटरवल है that is called as x minus x naught is less than equal to h. और अगर h is equal to a हो गया then it will be the complete length. Fine. Where h is called as the minimum of the a and b over m, where m is the bound of the maximum value of the function fx. A and b are the, what are the a and b? A and b are the length of the open rectangle. This is my a and this is my b. Fine. So I will explain you the interval of existence in the separate lectures. Fine, but in this lecture I will explain you only the existence solutions. Now the some important points which are very useful for the existence and the uniqueness theorem. So as I mentioned you, the existence and uniqueness theorem only give us about the idea of the existence of the solutions, but they will not give us any idea about where the solution exists or how you can find the solution for which the solution existence. That means x minus x naught is less than equal to h, and that h we can never know about from the existence of this solution. ये h तो हम existence से नहीं निकाल सकते. Fine. So it does not state about how the solutions or how we can find the open interval h. Fine. Second point, The initial value problem or the existence theorem does not provide information about how many solutions we have. As we can see, the existence and uniqueness theorem will provide you only about the uniqueness. Fine. But what about the infinitely many solutions? Fine. They will not give us. The existence theorem does not provide information about how many solutions we have. Fine. तो यूनिकनेस थ्योरम तो प्रोवाइड कर देगा हाउ मेनी सॉल्यूशन वी हैव द वन सॉल्यूशन, बट एग्जिस्टेंस क्या कहती है कि उसका सॉल्यूशन एग्जिस्ट करेगा करेगा। और आप दोबारा देखिए कितने सॉल्यूशन एग्जिस्ट करेंगे उसके, you can see at least one. If you look about that, at least one solution existence. So at least one means it may be one, it may be two, it may be three, and so on. So the existence theorem will not provide any information, but the uniqueness provide that only one solution existence. Fine. Another point is the uniqueness theorem ensure the solution is lies in the interval x minus x naught is less than h, provided this h is not greater than of the open rectangle A. फाइन, तो ये सिर्फ यूनिकनेस प्रोवाइड करता है, एग्जिस्टेंस प्रोवाइड नहीं करता है. नाउ make sure the condition of the existence and uniqueness are sufficient only but not necessary. For example, if you consider y dash is root of y plus 1 and your initial value is say y of 0 is 1, so can you define the rectangle? Your rectangle will be, how you can define the rectangle, x minus x naught. X naught will be 0 which is less than equal to a, y minus y naught which is less than equal to b. तो आपका rectangle, this is my x is equal to a, x is equal to minus a, this is my x is equal to plus a, and this number will be y is equal to 1 plus b, and this number is y is equal to 1 minus b, and your rectangle will be this part. Fine. Now you can clearly say your function f root y plus 1 is continuous. Fine. In the rectangle S, this is my rectangle S, because इस इंटरवल में कोई भी पॉइंट होगा, this is my 1 plus b and this is minus 1, sorry 1 minus b. इस rectangle के अंदर कभी ये पॉइंट इंफिनिटी को जाएगा फंक्शन? नो, द फंक्शन इज कंटिन्यूस. सो दैट मीन्स फंक्शन कंटिन्यूस है, दैट मीन्स एट लीस्ट वन सोल्यूशन एग्जिस्टेंस. वन सोल्यूशन तो मिल जाएगा आपको. फाइन. नाउ वी विल सी अबाउट द partial derivative with respect to y. It is 1 over root y, and clearly say whenever y will be approaches to the 0, this number will goes to the infinity. Fine. इसका मतलब Lipschitz condition not satisfy. Fine. तो अगर Lipschitz condition satisfied नहीं है, then there is no guarantee about the uniqueness. There is no guarantee about the uniqueness. तो यही तो हमने इस लेक्चर में डिफाइन करा था, 20 plus examples of the Lipschitz conditions. Fine. So as we can see, the function does not satisfy the Lipschitz conditions because del f upon del y is goes to the infinity as y goes to the 0. Therefore, we can never say anything about the uniqueness solution. Fine. Now, so what is the conclusion about the existence and uniqueness is whenever the Lipschitz condition satisfied, then definitely you will get the unique solution and that is guaranteed. Fine. However, when the unique solution, when the Lipschitz condition is not satisfied, then there is no guarantee about the unique solutions and it may or may not be unique. And how you can check about the uniqueness? We can apply the Picard's method. The Picard's method will provide you whether the solution is unique or not. And how you can apply the Picard's method? You can see my lectures, previous lectures on the Taylor's method, and this is the lecture of the Picard's method. Fine. And that lecture will provide you various examples, concepts, will provide you the examples whether it's a Picard's is a unique solution or not. Clear? Chaliye. So what is that? And once we are able to find the existence of the solutions, we always need x naught in this rectangle. As I mentioned you, if this is your rectangle, fine, around the point x naught and y naught, and definitely the length, this point is the subset of x minus x naught is less than a. What is the x naught less than a is ab. Fine. So x minus x naught is less than a is always, तो ये हो सकता है आपका fine is always with a subset of the x minus x naught is less than a. चलिए कुछ एग्जांपल्स आपको करके दिखा रहा हूं. फाइन. आफ्टर दिस वीडियो आई विल अपलोड द 25 प्लस और 25 और 15 प्लस एग्जांपल्स of the existence and the uniqueness theorem. अगर आपको चाहिए 15 more examples, you can tell me in the comment box. I will upload for you. चलिए सबसे पहले डिफाइन करते हैं rectangle को. Fine. You can define the rectangle. सबसे पहला काम existence and uniqueness में rectangle को define करना है. What is the x naught? 0. Y naught is 0. So we can define the rectangle S is a collection of all those elements of the x and y such that x minus 0 is less than equal to a and y minus 0 is less than equal to b, where a and b are my real numbers which are my positive. That is, you can say a and b are my strictly greater than 0. Fine. So that is my rectangle. If you look at this case, a is my positive, so it's from minus a to plus a. B is my positive, it will be from minus b to plus b, and your rectangle will be this number. Fine. And 0 is lies in between them. Clear? Now your target is to check about the existence and uniqueness. What is the f? Coefficient of the y dash is 1, so f will be xy. Now you can see your function f, which is xy, is it a continuous on this rectangle? And you can see x into y is my polynomial, and every polynomial is a continuous. So yes, f is my continuous on the rectangle S. continuous का मतलब क्या, ये वैल्यू कभी f की वैल्यू कभी इंफिनिटी जाएगी इस डोमेन के अंदर? नहीं जाएगी. हाँ, अगर आपकी डोमेन कुछ ऐसी हो जाती लेस देन इक्वल टू a एंड y इज लेस देन ऑफ इंफिनिटी, तो ये आपका इंफिनिटी पे चला जाएगा ना y के साथ. क्लियर? तो इसका मतलब ये फंक्शन कंटिन्यूस नहीं होगा. नाउ इन दिस केस द फंक्शन इज कंटिन्यूस, देयरफॉर एट लीस्ट वन सॉल्यूशन मस्ट बी देयर. तो इसका कम से कम एक सॉल्यूशन तो आपको मिलेगा ही मिलेगा. अब यूनिकनेस के लिए क्या करना है आपको? फंक्शन तो कंटिन्यूस हो गया, देन यू हैव टू चेक डेल एफ अपॉन डेल वाई. ये कितना है आपका? x. क्या ये कंटिन्यूस है आपका फंक्शन? द फंक्शन x इज अ कंटिन्यूस. यस, द फंक्शन x इज कंटिन्यूस on the domain S. Therefore, there exists unique solution. अब यूनिक सॉल्यूशन होगा कितना? x माइनस एक्स नॉट इज लेस देन h. वो हम बाद में फाइंड करेंगे, दैट इज कॉल्ड एज अ इंटरवल ऑफ एग्जिस्टेंस. वो इस लेक्चर में नहीं फाइंड करेंगे, वो अब थोड़ा पहले हम सीख लेते हैं एग्जिस्टेंस क्या है. और अगर आपको इसका सॉल्यूशन निकालना हो तो कैसे करोगे आप? यू कैन फाइंड, ऐसे तो करोगे ना. You can integrate on the both side, so that will be log of y, which is x square by 2 plus c, and y will be your e raised to power x square by 2 plus c. Now clearly say whenever x is equal to 0 and y is equal to 0, you will get c is equal to e raised to power c. E raised to power c is equal to 0. So what is the c? Can you find that solution? Can you find the solution? There is no value of the c. Fine. Or I can say e raised to power x by 2, e raised to power c. Fine. So e raised to power c आपका 0 है, so your solution will be only the 0 solution. That means y of x is the only solution which is unique one. Look at the second one. Consider the initial value problem. Does the existence and uniqueness solution exist? So what is the initial point? Initial point is y is equal to 0. मतलब y naught is 0. What about the x? X can be any number. Fine. So your rectangle is x minus x naught is less than of the a and y minus 0 is less than equal to b. That is my defined rectangle. Fine. क्योंकि आपको देखो इस केस में सिर्फ y के बारे में बता रखा है, x के बारे में नहीं बताया. So x can be anything but y must be 0. So we can define the rectangle. Now we will firstly define the existence for the function f. Existence means we need to check whether the function is continuous or not. How you can check the continuity? We can take the limit y approaches f of x comma y. If this limit is equal to f of x comma 0, then you can say the function is continuous. So let's start with the limit. Limit y approaches 0, y cos of 1 over y. And if you take y, that function is my bounded. Cos of 1 over y is a bounded, so that number is my 0, because cos 1 over y is bounded function. Fine. Moreover, you can apply the sandwich theorem as well if you want. Cos of y 1 over y lies between -1 to +1. Fine. If I multiply y on the both side, then it is a y cos 1 over y is less than of the y. And now you can take limit y approaches 0. The left hand side becomes a 0, which is limit x comma y is less than 0. What is the meaning of that? Function is a 0, and which is same as function of x comma 0, because whenever y is 0, limit is 0. So therefore your function f is continuous at the initial point x naught comma 0. Fine. So that means if the function is continuous, by the existence theorem it has at least one solution. अब क्या इसका यूनिक सोल्यूशन होगा? We will apply the Lipschitz conditions. Let's start with the partial derivative of the f with respect to y. Fine. You can simply differentiate them. 1 into cos 1 over y plus y. Cos will be minus, fine, into 1 over y square. So that will be cos 1 over y minus 1 over y sine 1 over y. Or you can apply the definitions, that is a limit y approaches 0, f of x comma y minus f of x comma 0 divided by y. तो ये कितना आंसर हो जाएगा? लिमिट y approaches 0. What is the value of the f of x comma 0? Y is 0, function is 0. This number is a y cos 1 over y. Y and y will be cancelled. It's a cos 1 over y. Clearly say the limit cos 1 over y does not exist. Fine. और यहां से भी देख लीजिए. So whenever y it limit does not exist, because cos, or moreover you can see what is the value of the 1 over y, that goes to the infinity as y goes to the 0. So that means the Lipschitz conditions does not satisfied. Once the Lipschitz condition is not satisfied, then you can say that there is no guarantee about the unique solution. तो इसका unique solution हो भी सकता है, नहीं भी हो सकता. तो उसके लिए मैंने क्या बताया? How you can check about that? We will apply the Picard's method. And what is the Picard's method? The solution is y of n plus 1 is yn, or you can write instead of the yn is y naught plus integration from x naught to x f of x comma y of n minus 1. ये तो Picard's method था आपके पास. Fine. In this case, what is the y0? Initial value is my 0. Fine. And what is the function? F is my y cos 1 over 1. Fine. So let's start with this one. So can you find the first solution? Whenever n is 1, y naught is my 0 plus integration from 0 to, sorry, x naught is not given to us. That number is my x naught, which is f of x comma y0. Y0 will be my 0. Fine. So can you find the answer? 0 integration from x naught to x. What is the value of the f of x comma y0? That is my 0. Fine. So y1 will be 0. Clear? Similarly, can you find the y2, which is y0 plus integration from f of x comma y1 of dx. What is the value of the y1? Y1 we have obtained as a 0. So I can write this number as a 0. And again, what is the value of the f of x comma 0? Again, 0. Similarly, you can find the y3, which is again integration from x naught f of x comma y2. What is the value of the y2 is 0. Again, you will get as a 0, and so on. So the last term yn is also 0. तो इससे क्या मीनिंग हुआ? From this case, we can see y of x is always 0. And what is the meaning of the 0? Is the only unique solution. Fine. So that means at least one solution we have obtained from the existence part, while the at most one, that means we will see this initial value problem has the unique solutions based on the Picard's methods and the existence and the uniqueness theorem. Fine. So this is the way you can think about the existence and the uniqueness theorem. अगर आप चाहते हो कि more than 15 examples in the next video, you can tell me in the comment box. I will upload very soon for you. Till then, you can share this video with your friends, like and comment on the videos. Best of luck, students. Happy learning always.